Welcome to Unit 2, Lesson 3. This is called rational expressions. Just so you know, rational just means fraction. An expression is a term that does not have an equal sign, right? So as soon as you put equals something else, that is not an expression anymore, it's an equation. Um, so this is like a quick mini lesson, right? So if you have x squared minus 4, you can never cross this out, okay? And you can never go like this. So you factor the top, x plus 2, x minus 2. The bottom is just x plus 2. These cancel out. You're left with x minus 2 over 1. If there's anything divided by 1, it's just itself. So our final answer is just x plus 2, okay? So we're going to go ahead and do a problem. Here's model problem number 1. So it says simplify the expression. So at the top right here, we have 3x minus 9. So what's our common factor here? 3. So we're going to take that and factor it out. So 3 times x gives us 3x. To get that minus 9, we do minus 3 because 3 times negative 3 gives you negative 9. Okay, so this is the top factored. Um, so think of first step is to factor out the GCF. So that's our greatest common factor, which in this case is 3. And then we're basically taking that 3x and that minus 9 and dividing both sides by that greatest common factor. 3x divided by 3, these cancel out, you're left with x. And 9 divided by 3 is 3. That's where that comes from, another way, okay? On the bottom here, we're going to do something similar, right? We have x squared minus 3x. So we see that there's an x for both of these, so we're going to take that x out. So if I divide this by x here, divide this by x here, right, this is going to cancel out. So you're left with a minus 3. And then x squared divided by x is going to give us x. And I can check it by doing distributive property. Now is when I take my red pen, because as soon as I see the same thing on the top and the bottom, I can cancel them out and I'm left with 3 over x. Done. Okay, so that's model problem number 1. Model problem number 2. You need to remember what we did in the do now. Just gotta go back to this real quick. So in the do now, if you have x plus 4 divided by 4 plus x, same thing on the top and the bottom, they're going to cancel out to give you 1. X minus 4 divided by x minus 4, that's a 1 as well, right? And I can check that by putting 5 here, right? 5 minus 4 is 1. 5 minus 4 is 1. 1 divided by 1 is 1. 6, if I could use 6 as well. 6 minus 4 is 2. 6 minus 4 is 2. 2 divided by 2 is 1. Over here, right? If I say x is equal to 6. 6 minus 7 is negative 1. 7 minus 6 is 1. Negative 1 divided by positive 1 is negative 1. So this answer, when I flip them, right, and there's a minus sign between it, it's always going to give me a negative 1 as our answer. Okay, so this was our do now. And that's going to help us to do this model problem number 2 that we have right here. So we look at x squared minus 49. So we're going to see what does that factor to be. Let me go back to the blue because I'm not doing any crossing out yet. So at the top right here, I do parentheses, parentheses. It's going to be a double bubble. To get x squared, I have an x and an x. To get 49, 7 times 7 is equal to 49. To get this to be a negative, one has to be plus, the other one has to be negative. On the bottom, I just have a 7 minus x. So what did we literally just learn right now, right? In our do now, these two do cancel each other out, but our answer is going to be negative 1. So what is my final answer, right? Negative 1 times x plus 7 is one answer you could put. You could also distribute this right here. So negative 1 times x is negative x. Negative 1 times 7 is negative 7. So that is your answer. Okay. Model problem number 3. So rewrite in simplest form, then determine what values makes the expression undefined. So in simplest form, first we're going to do is find a common denominator here. So if there's no denominator right here, there's an imaginary 1. We kind of just talked about that, right? To get our denominators to be the same, we're going to multiply this by x plus 5. Whatever you do to the bottom, you do to the top. X plus 5. And so now we have, on the bottom, we're going to have x plus 5. And on the top, we have 4 times x is 4x. 4 times 5 is 20. minus, and this whole thing together, right, is on the top. So I have x minus 3 here. So I can simplify this right here, right? So I have 4x plus 20, and this is, there's an imaginary 1 here. So 4x plus 20 stays, and then negative 1 times x gives me negative x. Negative 1 times negative 3 gives me a plus 3, and it's all over x plus 5. And then I'm going to combine like terms here. So I have 3x, right? 4x minus x is 3x. 20 plus 3 is 23, all over x plus 5. So that's the first part. So I rewrote it in simplest form, and then it says, and then determine what values make the expression undefined. Undefined just means we're going to take our denominator right here. So I'm just going to write this down, undefined. We're going to take our denominator, which is x plus 5, and we're going to set it equal to 0. This denominator can never be 0. Uh, and the reason why is because if you take your calculator and divide any number you want by 0, you're going to get undefined. So I'm going to do minus 5 here. This cancels out, and I left with x is equal to negative 5. So this number right here is what makes it undefined. Is, let's say, makes expression undefined. All right. So that's model problems 1 through 3. There is a check for understanding here that I'm going to ask you to definitely try. And then do a couple of problems, and you should be good to go. All right. Thank you.